Hello, and welcome to another episode of the Super Data Brothers Super Show. I am Ryan, and I'm flying solo today because Eric got a new job, and it's his last day at his old job, so his coworkers are taking him out to lunch. I'm holding down the fort by myself, but we have got an awesome show for you today. We have got Brenna Buuck from MinIO joining us to talk about lakehouses, on-prem, on cloud, why you want them, what they do, what they don't do. We're going to get into it. Now, listen, if this is your first time at the Super Data Brothers show, this is a live show, folks. It's not pre-recorded. Do not treat this like some boring-ass corporate webinar. This is like a Twitch live stream. Get your questions and comments into the chat, and I will get them into Brenna, and I will read them out. And if you let me know where you're watching from, I will give you a shout-out right now. So go ahead and get them in, and we will kick things off here at the Super Data Brothers, whether you're watching on LinkedIn, whether you're watching on YouTube, whether you're watching on Substack, whether you're joining us on Twitch. We are live almost every Thursday at this time. So who do we got tuning in? We got Lynn Bender saying good morning and a 20-second lag on LinkedIn. LinkedIn sucks for live streaming. I'm just going to be honest with you. So I'm aware of this issue, and I'm sorry, there's nothing I can do to fix it. If the lag on LinkedIn hurts your viewing experience because it takes me so long to see your comments, switch over to YouTube or Substack and watch there, because the stream is much more live on there. And then we've got Michael Dunphy tuning in again. Welcome back, Michael. Hello, happy holidays, Ryan. And he says the Super Data Brothers made it into my YouTube Wrapped this year. That's amazing. Thanks for sharing that. That is so cool to hear. I just watched my YouTube Wrapped this morning, so it was awesome. Awesome that I actually made one. I'm quite flattered, actually, that you join us so regularly, Michael, and a great participant in every episode. So thanks for being here. And then Lynn says that's not the only thing LinkedIn sucks at. Yeah, a lot of unhappiness at LinkedIn in the data community lately. I will say that, and I share that unhappiness, and we can have a bigger topic about a conversation about it during the show today if you want. Of course, Lynn, the organizer of Data Day Texas, which, folks, Data Day Texas, if you've never been to, it's my favorite data conference of the year, and I actually run a data conference. When my own conference is probably second, to be honest with you, behind Lynn's. So check out Data Day Texas. If you use the code Super Data Brothers, all one word, you will get a discount on your registration for Data Day Texas. And also, Eric and I were proud to sponsor the Open to Work half-off tickets for Super Data or for Data Day Texas this year. So that's another awesome program Lynn is bringing to the data community. Thanks for joining us today, Lynn. All right, we're going to bring Brenna on in a second. So load up those questions, comments, and hot takes about lakehouses and on-prem versus cloud data. Before we do, I just got to thank today's sponsor, Good Data. Now, two things I want to draw your attention to. These will both be very educational and edifying for you if you check them out. And that is two articles by Donald Farmer, former Super Data Brothers show guest and data industry legend. Go into the back catalog to check out our interview with him. It was phenomenal. These two papers, one covers the topic of analytics as code. This is building your front end, not in the traditional BI way by clicking and dragging and taking 16 months to build a dashboard that when you deliver, nobody ever needs. This is about architecting your BI using code, treating it like engineering and not clicking and dragging on a user interface. The advantages of doing it this way are huge. So check it out. And then also the Analytics Lake. This is our architecture designed to house your data, your knowledge and semantics about the data, and your analytics objects, charts, graphs, dashboards, chatbots, all in a single layer, right? So you can have the data, the metadata that describes the data, and the outputs of the data that your end user consumes all in one place. A very exciting architecture and two great papers by an incredible writer in our industry. So look at the QR codes, download them, read them, reach out to me and let me know what you thought once you do. So Carl asks, is this a live show? Because it's better when it is. Absolutely, Carl. This one is live. So get your questions and comments in and we will ask them whether you're watching. Again, YouTube, Substack, LinkedIn. Looks like we're not on X today because the integration failed, but nobody watches us there anyway, so it's no big deal. And without further ado, I'm going to welcome Brenna Buuck to the Super Data Brothers show. Brenna, thanks for joining us.
I'm happy to be here.
So I really wanted to talk to you about lake houses and what's going on in lake houses. But before we dive into the nerd stuff, why don't you tell us a little bit about yourself and your background?
Good question. So right now I'm a developer evangelist at MinIO. But prior to that, I was a real data engineer for about 12 years. And prior to that, I was a political science grad student in San Diego. And so came at this career kind of at an angle. But it's something I have a lot of passion for, which is why I wanted to go. I switched from real engineering, PagerDuty, PR reviews, all that stuff into doing more of a marketing angle, because it's something I really enjoy talking about. And when you're just working behind Jira tickets, you don't really get to talk to a lot of people. So now I say I'm a free elf. I get to go out into the world and talk to people about my favorite subject, which is just data and steam trains. If you want to switch over to that.
That's my other show. But now that I know, you can join me on that one too.
All right. So, but those are my two favorite.
Yeah. That's an interesting combo. I do, because you initially studied political science, and then you kind of made this transition into data. And I'm always fascinated to talk to people who come at data from something else. I was a theater, I was an acting and playwriting major at undergrad. I once had a boss who was a performance trumpet major when I was a sales engineer at a different BI vendor, a decade ago. You come from political science. So two questions really, what was that transition like? And then, is there anything you learned in poli-sci that you think helps you as a data person or gives you an advantage versus people who just come from a strictly technical background?
Oh yeah, for sure. I'll just answer the first question, how I came into this. So, well, I graduated in 2008, which was a not great time.
Yeah, 06 here, so yes.
It was a not great time to be in humanities. And so because I had to, eat, I joined a startup and taught myself how to code, basically, just to stay employed somewhere doing something. I was really big draw for me was that it was a startup that had free food. So, so coming from grad school where that's also a priority, there was a nice blending of interests there. But to be honest, coming from the transition isn't as wild as you might think. Political science has a lot of stats background. And so I sort of moved into a business analyst role in my first startup job. And it required a lot of, things in Excel. I could do a pivot table coming off the bat, and that was sort of kind of appealing to employers. And so I was also political science and research in general is about puzzles. And I feel like that's also what working in data is. You have an end goal that you want to achieve. You have to deduce the steps that will take you to that outcome, and it's sort of like a Rubik's Cube or a jigsaw puzzle, because all you have is little pieces and you've got to put them together to get the final result. So I was also thinking when I don't know if you ever took those gait tests when you were in elementary school, where they'd show a piece of paper and then they were well, how do you make the monkey at the end? And you have to think through the steps in order to get to the final result. And I think that's a lot. That's 90% of what pipeline data engineering is. What do you start with? What's the state of the data to begin with? what steps do you need to like do in order to get it to the final result. And you start off not knowing, sometimes not even knowing what the current state is, but you have an idea of what you want it to be like in the end. So I do feel like there was, I don't know if I'm more like advantaged than somebody coming from like a traditional educational background, like poli-sci, or even towards the like middle part of my career in data engineering. I started to be like data engineering degree specifically. You know, I don't know if I'm like more advantaged in them than otherwise I would be, but I'm more hungry, I would say.
Yeah.
Like I had to I taught myself how to code. Like I taught myself SQL and then Python. And then I learned a little bit of Scala, not enough to be dangerous, probably enough to vibe code now, but like, and then I was forced to learn a little bit of React to when I was a real engineer, because they wanted us to be like full stack so that we could display our charts and graphs ourselves, which is like sort of a painful learning process because React is like very emotionally abusive, in my opinion.
Okay, you should have you need a shirt that says that.
Yeah. I don't want to offend anyone that's like a front-end developer, but I would say like they shouldn't make regular engineers do front-end development because we don't know how to make things pretty. At least I don't know how to make things pretty. Like I would have I from time to time have to make decks, and like I hand them over like and they're never up to the design standards that the design team has for beautification. I was like, but it has everything. Like it explains the whole thing. Why do we need more? But apparently it's an important part of the design process. So
yeah, I mean, a lot of what you just said resonates deeply with me. I especially that last bit about not being like my decks are notoriously bad. And it's just, you know, and I think people sometimes come to me, they're like, you're the arts guy. Like, why are you so bad at this? And I'm like, writing.
No, I think I'm a good writer. I aspire, well, at least I aspire to be, and I also aspire to be a good communicator. But and I do appreciate like the visual. Like I love charts and graphs. Like because like I said, I started as a business analyst. I made a lot of dashboards in my time, but I like them simple. So because I think that the information is what should be apparent, and it's what should shine, not your razzle dazzle. But that's not the opinion of the greater world. So we're just engineers doing our best here. That's all.
Yeah. Got a couple comments here. One from Michael. He says, "Hey, that's like me. Political science, computer science, working in the political data world. Exciting space." And then Johnny Winter. Whoa, my BI mentor did a music degree and was a tuba player. I studied politics and philosophy, which turned out to be the perfect preparation for debating what the fuck a data product is. And I agree, Johnny. Like, I think there's certainly I think if you look at the people, say on social media in the data space, who raise their hands and say, like, I'm someone who wants to talk about this, there's a self-selection of people who came from other fields, especially fields maybe where you sit around a table and debate a text.
Yeah.
Right. And I mean, that's definitely playwriting, right? You're talking about problem solving in data and how in political science you learn to like deconstruct problems. And in a weird way, I learned the same thing in playwriting. There's this great book. I normally have it on my desk, but it's not here right now, called Backwards and Forwards, that teaches you how to read a play. And what it says is you read the play once, you just read it and you just take it in, right? You're not analyzing it at that point. And then you actually start at the back of the play and you read it backwards. So you go from like, what is the end state? And then what was the previous state? And what was the state before, all the way to the beginning of the play, as a way to understand the evolution of the characters and the storyline throughout the play. And I've always applied that to my work in data, where like I really want to start from what is the end state we're looking for. And that doesn't mean 3 dashboards in this new data mart. It means here's what we're trying to accomplish in the real world, right? And then let's move backwards into, well, what analytics objects do we need? And then what do we need in a database to support that? And then what do we need in a data pipeline? And then, all the way into our fundamental architecture if we can. A lot of times the fundamental architecture is set for you. So, you got to use what's there. But it's just fascinating. It's fascinating. It's funny because I think you get it and I get it. But one of the things I see online is a lot of people who come from a strictly technical background really struggle to learn this. This kind of working backwards, working from outcomes, because they've learned all their studies were about the fundamental technology and the techniques about the fundamental technology. Whereas if you come from an arts background or a poli-sci, just humanities background, you're used to thinking the other way, right? Here's the conclusion. How did we reach this conclusion? And I do think it's an advantage. I've found it to be an advantage for me. I don't know. But that's all cool. Let's talk about technology. So one of the reasons I want to talk to you is I see in my customer base, not a huge, but a real, I would say it's fair to call it a small trend right now of people who are looking at either moving some part of their data on-prem or are looking at spinning up new capabilities, and they're thinking on-prem first. And some of this is regulatory. I have a lot of customers in Europe, and in certain, especially if you're in a German-speaking country, their cloud adoption is much lower than in the United States for regulatory and cultural reasons, right? But I wanted to get your take on that and about the state of lakehouses and in general, and in particular Iceberg. So why don't we start with just some table setting here? What is Iceberg? What is a lakehouse? And what do these things have to do with one another?
Cool. Okay. So a lakehouse is really interesting. Some of most people that are familiar with data are familiar with databases and data lakes, and a data lakehouse combines the best of both of these things, but does it in a disaggregated way. So, and that's the disaggregation part is really interesting because that means you can swap and drop components. There's three main components. I'll go back to the difference between data lakehouses and databases in a second. But I want to just, before I cover what it isn't, I want to just cover what it is, which is, it has three main layers. So there's a compute layer, which is usually a query engine, and the ones people are familiar with are like Dremio, Starburst, Trino, Spark, that can be a query engine, and then your open table format layer. So a lakehouse doesn't have to be Apache Iceberg. There's actually 3 open table formats on the market today: Apache Iceberg, Apache Hudi, and Apache Delta, which if you're familiar with the Databricks Lakehouse environment, that's the one that they use. Hudi came out of the Hadoop ecosystem, and it's optimized for a very particular workload, which is streaming. And so if you have like a legacy, if you're coming out of Hadoop or you are doing a lot of streaming, that might be the open table format for you. And then which brings me to Apache Iceberg, which is the most widely adopted open table format. It's got the approval, the tacit approval, or the full approval of big data players like Snowflake, Databricks too. Snowflake in particular with their open sourcing of their Iceberg catalog Polaris. All of these, they all have different, like I said, I kind of already started to go into the details about how they're different. Iceberg has wide adoption because it has wide integration with a lot of other systems. Databricks only does Delta Lake. Hudi, like I said, is centered in that Hadoop background. So if you're still in that like ecosystem, if you're using Spark exclusively, if you have Hive and you want to keep it, things like that. And you're also, the other use cases, if you're doing active streaming, that might be your guy. But most people batch. And most people, you want to use a lot of different options in the marketplace. And Iceberg has this huge adoption of everything from BI tooling to vector databases to AI modeling tools. And so, if you kind of want to be in the stack, that's your guy. It brings cool stuff like this is the layer that brings what actually makes a data lakehouse, I think. The disaggregation part, but also just this, what people think about when they think about lakehouses being awesome, this is where it is. Like time travel, a schema evolution, a partition, automatic partitioning, stuff like that. So, and to describe what that actually does in practice as a practitioner, like as a user, as a data practitioner, or like an end user, like a BI analyst, those things allow you to send data into your data repository without a strict schema. So if you have experience, we're going back to the beginning where I talk about the difference between data lakehouses, databases, and data lakes. A database requires you, if you pipeline data into it, to know what the eventual schema is going to be, right? So if you have, if you're trying to put in data from a CSV, let's say, which is a very traditional use case, or maybe it's JSON, whatever you want to imagine it, the first part is. If you're putting it in, you have to know what the columns are going to be and what the data types are going to be. So I'm sure everyone who maintains pipeline has some horrible experience where something starts off as an int, like a column starts off as an int and then suddenly isn't. They start using words in your very special column that you have in your database, like doesn't exist, or I don't feel like writing this, or whatever, and your pipeline breaks. So the beauty and the glory of a data lakehouse is that because the schema can evolve, you don't have to pre-describe what the schema is going to be. You can just pop all of your data into your repository. And this motion is actually very similar to that of a data lake, where which is the next evolution of a data lake. So, sorry, a database. And this sort of arose, a great example, or an the oldest example of this would be Hadoop, right? It's just big repository and people just dump all of their information in it. And it's great because you can collect everything that you have in your org, all, your PDFs, your both structured and non-structured data, your JSON, your audio files, your whatever you have, it just can all go into one space. And the problem with that is the same problem that sock drawers have, right? If you dump all your data into one huge bin, it becomes very difficult to find a specific thing you're looking for. And often we, as data practitioners and as end users, too, we're looking for a specific thing. How many widgets did we sell in 2018 or whatever? And if you can't find your specific thing, so really your data lake is not going to be functional for your org. So you have it's got pros in that everything can go in it, unlike a database, which has to have, it can only accept certain data formats, and then has to have a strict ordering inside its its repository. You have to have a strict schema. You have to think about indexing. You have to it's more highly structured. But with a data lakehouse, you get all of it. So you get to be able to store all the data that you want. You don't have to have a strict schema enforced as you pipeline your data in. So you're gonna get less brittle pipelines. And you can, a query engine like Dremio or Starburst or Trino or whatever flavor of query engine you want, can query your data as if it was in a database. So it's very familiar. Usually they have SQL interfaces. They organize data into tables that we're all familiar with. But it's more a lot more flexible than a traditional database. I hope that answers it.
Yeah.
Basically,
No, there was a lot of great stuff there. My first question is, based on what you've described, so the architecture of a lake house, is it that, okay, you've got something that resembles a traditional data lake. It's not Hadoop anymore, and we can talk about Hadoop if you want. But I have less than stellar experiences with Hadoop.
No, it's
yeah. It was God. So many clients of mine spent so much money on Hadoop in like 2016, and nobody got anything out of it. It was bad. And then so you've got, say, Iceberg. And then there's two things you could do. You could put Snowflake on top of it, or you could use one of these query engines to just query Iceberg directly. Mm-hmm. Why would you choose one versus the other?
Well, you don't have to. So that's my favorite part about a data lakehouse is that it's good and it's bad. And I want to just be full transparent about like the limitations to a lakehouse, so that you're not like I'm a professional advocate for data lakehouses, but there are some things to consider when you're thinking about the architecture. And as always, you want to make sure that you align your workflows and your goals to whatever architecture you choose. So that you should consider these downfalls. But its pro is also its con. So its pro is that you can have multiple query engines operating on the same set of Iceberg tables. So if sales uses Snowflake, well, you can use external tables or an external catalog or whatever to query the data on-prem or wherever in another cloud, wherever you want to, wherever your data is, and put it into Snowflake as if it was a regular table. And the same, if you put it directly into Snowflake, no one else is going to get it, right? We're clear on that. But you can also say your marketing team wants to use Dremio. Well, you can still operate on the same data set without migrating it. And if your data science team is like really into PyIceberg, which is like a Python flavor of a very light query engine that doesn't require a JVM, which is also just as Hadoop has emotionally abused, Spark has emotionally abused. So, very powerful, still very present, unlike Hadoop. And there's a lot of use cases, and we love Spark. Is it difficult? Yes, but they can do that. That's the glory of it. So you can have multiple query engines operating on the same data. But the other side of that coin is that you can have multiple query engines on the same data. So say you have like very strictly enforced like role-based access control in Snowflake, and you only want the salespeople to be able to view these tables without and not be able to edit them. If they pick a different query engine to operate them like Dremio, and they can do whatever they want to, that the role-based access control is gone, right? So it is the coolest part of it, but is also like tricky from a like a security point of view. And now you might be asking yourself, okay, well, if I can have all these query engines, what happens if like two query engines or like even two users on the same query engine try to update the table at the same time?
Yeah, are we locking tables here? Is that what happens?
So you can do that, except that within the query engine. But if that won't help you if you've got two different ones, right? So Iceberg has its own solution. That's just an Iceberg thing. That's just how it is. It's called optimistic concurrency. So if you send Iceberg two changes to a table, it will only accept the first one and fail the other one.
Gotcha. And
so this is maybe another reason why Iceberg might not be the best for streaming, like fully streaming use cases. It's what Iceberg is, what it is, right? It's part of the spec, but it does mean that you can have these concurrent engines operating on the same tables, and you never have to worry about like the data being corrupted. Iceberg is enforces asset guarantees, just like a traditional database. And so you're trading in some flexibility that comes with like a fully streaming concurrent, like high, like high transaction environment. Although Iceberg can handle it to some extent, and probably for most people's use case, it'll be fine. If you were like a day trader, like accepting transactions from all of the world instantaneously and your milliseconds matter, that's probably not your guy. If you're, you have a data lakehouse that is, fronting an enterprise BI analytics platform, that's golden, right? You care about more that the data is correct than you do that the data is fast.
Yeah.
So
I think that leads really nicely into Michael's question here, which is, do you think Apache Iceberg will eat traditional databases since it's becoming pretty similar in practice, but has greater flexibility?
Yes. Well, so I have yes and a caveat. So lakehouses, Apache Iceberg lakehouses in particular, is the new thing. Like this 100%. It's new because it's fast. It has asset guarantees. It does everything you want a database. Like, so when you traditionally in a database is another little caveat or another little point about the difference between the two. So when you like dropped a table, accidentally, as we all have, I assume that it's not just me. You'd have to like contact your admin and ask them to see if they in the tape or whatever.
Yeah, that's when the groveling begins.
I'm so sorry. Can you just roll this back? And I'm like, it happened. It just happened. Like, I can't believe that. And it took hours.
Blame it on Claude.
With Iceberg and time travel, so every time there's a transaction, so every time there's a change, you add a column, you add a row, whatever, any CRUD operation, like insert, update, delete, a record in the metadata gets saved. And you can roll back to any previous version of that metadata anytime. And you can do it, I can do it, the guy downstairs can do it, sales can do it. So like if you mess something up, you can just go back to an earlier state. If you do this elaborate pipeline and suddenly your boss says, you got rid of my favorite field, and you spent 6 months building up this pipeline, editing it out, just roll back to the point where it's there, and then you're good to go. So it has, so yes, absolutely. I think it's going to replace databases. There's a caveat in that in order to have an Iceberg Lakehouse, you have to have an Iceberg REST catalog, which is the part that does, so Iceberg in itself is just Parquet files and a metadata bucket, basically. The cool stuff, like the time traveling and the partition and the schema and the what have you, that's from the Iceberg REST catalog, and you have to have one. And if you don't have your Iceberg catalog embedded into your object storage, that's in the, I only talked about the 2 layers of a lakehouse. The 3rd layer is object storage. All lakehouses have to be on object storage. That's just how the architecture of Lakehouse does.
So that would be like S3 or whatever.
Yeah, or MinIO or whatever.
Or MinIO, yes.
Or like Google Cloud or Azure Blob. It has to be object storage of some kind. It doesn't matter what kind. Your flavor is your own discretion, but it does have to be object storage. So the point I'm going to get back to if you don't have your catalog inside your object storage, you have to have a transactional database for your catalog. So that's usually SQL or Postgres. Now, to be fair, a metadata for Iceberg is usually, even if you have it's really small, right? So the Parquet files are the majority of the table. The metadata is like teeny tiny, right? So it's not a huge database, but all Iceberg external catalogs, external from your storage, have to have a transactional database. So it's kind of funny. We're getting rid of traditional databases by also having a traditional database. So, but yeah, no, I think it's going to, I think there'll always be a need for a traditional database for like pure transactions. Like if you have like a POS system or something, and like you don't anticipate like the data, like the columns changing. I mean, there's really nothing better than a database for that. But if you're talking about analytics, BI or AI, Lakehouse Iceberg will eat up, I think, traditional databases, because they're just so much more flexible. There's just nothing better than being able to know that your pipelines won't break at like 4 a.m. right before the earnings call, like.
Yeah. And I think one of the interesting things from my perspective is that the inflexibility of data warehouses in particular has led to a set of cultural practices when it comes to BI and analytics of being quite rigid, right? About how we develop, what our processes are, because making changes to a data warehouse is usually very painful.
Yeah.
And so you don't want to do it. And you find ways around it. And then that leads to all these downstream problems. So just a simple example that I'm guilty of, having done this at least 100 times in my career. Someone comes to me with some new data and we want to get it into BI, but we know that putting it through the DW workflow to add these 3 new metrics into the star schema that we modeled is going to take 6 months, just because of the way it is. So instead, I take a CSV, I add it directly in the BI tool, I join it to the star schema in BI, and now I have those metrics in my dashboards. But I've totally crushed things like data quality. I've potentially hurt performance, because now we're doing this, we're doing these cross-source joins in BI, which some BI tools handle great and others really suck at. What does that world look like? So let's imagine now I'm on Iceberg and someone comes to me and says, we want to get these 3 new metrics into BI. What does that look like for me?
Yeah, well, I do hope that we learn from, the past, and still the Kimball methods, star schema, medallions, they all still have a place in like modern architecture, for orderliness. And that's part of what Lakehouse, right? So part of Lakehouse is that when you're as a user in the query side, it operates like you think a database should, right? The cool stuff is sort of in the catalog away from you, to the most extent. So I'd say we don't want to like throw the baby out with the bathwater, but I think that the cool thing about a Lakehouse is that it sort of democratizes like analytics and AI and BI, in that you can put anything in a Lakehouse and you can connect it easily to anything else that's in there. All of your stuff can go in there. You don't have to be like precious about it. And with the state of storage right now, which is extremely cheap, you don't have to be weird about keeping things that are 10 years old or 20 years. You don't have to like run over and put it on tape as soon as the month passes. Those things are sort of out of being out of the way with a Lakehouse. So this whole idea where we have to be like really careful about what we put in there is out the door. And then, but we're still able to find it. So like,
Yeah.
I think there's going to be a balance, and I think as Lakehouses evolve, we're going to like between these old methods of data modeling, which no one likes to do. You should, for like lineage, security, data validation, data cleanliness. You have to care about that, but you need to sort of find the balance. So can you put anything you want in your Lakehouse and do some vibe coding and connect it to anything you want, and it'll be kind of rickety, and you'll probably be fine because it probably won't cost you that much, especially if you're on Prem, and you're not paying for the transactions. You're probably all right. If you are worried about your cloud spend and you you need your query to operate pretty fast. Like your BI users don't accept queries that take longer than a couple minutes, and you can't cache or materialize. Then you're gonna have to start schema. You're gonna have to figure out how you can make your data more orderly. So with all things, I'm sort of like muddling this question, but because I think I honestly think it's sort of a balanced question. Like you can just put anything you want to and connect it to whatever you want to, and anyone can do it. And the great thing about it is if you put it into a central warehouse instead of just in your BI tool that only you can access, you have this opportunity to sort of institutionalize that. Like your first version can be kind of sloppy, and then because it's there and it's readily available for everyone to integrate with, you can. And of course, you can go back to earlier versions if you mess it up. You have this tremendous opportunity to institutionalize these vibe coding opportunities to be something more rigid, or like less vulnerable, or more enterprise level. So like it's just a balance, like with all things. Like, can you do it? Yes. Should you do it? I don't know. Maybe like, can you afford it? Like time, money, with all things, I think you just have to find balance. But the cool thing about Lakehouses is like you can decide yourself what your SLA. We'll never tell you. Like, I think being at MinIO, especially because we're the storage layer, so we just kind of see. I feel like it's like being on the bottom of the ocean. Like you see all this like drama thing above you. Like you can see like warships going on.
The ships pass, yeah.
And you're just like, I think. It's not our place to like tell you which like warship or which model or which data set or whatever you want to use, but because all are available to you, you just have to think about what makes sense for your workload and your use case, and what level of risk you're comfortable with, I guess.
You said something there that I think is really important, and it factors into one of the main topics of this show over the last year and a half that I've talked with a ton of guests about, is this idea of data products and product thinking in data. And one of the traditional barriers to that has been the rigidity of the data stack. In product thinking, you move fast, you come up with an MVP, you ship it, you measure value, and then you either continue to build out when the value is proven, or you abandon it and move on to something else, right? That is the way we do things when we're really embracing the product lifecycle. And in the old world of ETL into Kimball schema into BI tool, that whole process was so painful. Yeah. You really could not engage in this product thinking. You could not build and ship fast and then realize, oh, that thing we shipped doesn't work. Yeah. And now let's move on to something else. That was too expensive. But it sounds like, and this was a big light bulb for me based on what you just described. I mean, it sounds like Iceberg helps solve part of this problem, which is we can get the data in there, get it clean enough to do the MVP, to do the test. Yeah. And then if it's valuable and we see, oh, there's a need for a Kimball star. All right, now let's build one. Yeah, instead of having to decide that up front and then build a Kimball star, which nobody uses, which I have to tell you I've done, right? Because there was no other way to do it back then. So this is a huge problem that I think this technology helps address.
Yes, I absolutely think that it accelerates the speed of innovation. Like you can get faster, anywhere faster that you want to go. But you can also formalize your processes later on, and that's where the database part of the benefits of a data lakehouse come from. You get the best of both. You get like data lakes were cool because you could shove everything in there, and you can do some like cool like little vibe coding stuff really fast and get stuff done. You'd immediately forget where the data went, but it was there for your use. There's the two together, right? Like it's all of the innovation acceleration of a data lake, but the possibility of like a real live enterprise data system at the end. So I love that about data lakehouses. I think that I really, as a data engineer, I spent most of my time maintaining broken pipelines, and I feel that, which is boring and like repetitive and like not the best use of my time. But of course, you know, that's critical. This solves so many of those problems. And you get, along with the lack of broken pipelines, you get a boost in your data quality, right? Because if you're not, I'm sure all of us have experienced like a silent failure where like all of a sudden you say you're getting like 1 million records a day and all of a sudden you get like 1,000. You might not get, you know, your observability tool might not tell you that there's a problem inserting the records, but there's a flow problem, right? This solves that problem by shoving anything you got in there. So your data quality improves, your time frees up, your data lineage is like perfect because you can see from where it came from, right where it goes at the exact date of the transaction that it came in. It's perfect, like for data lineage, you know. So I don't know that I'm a big fan of lakehouses.
Yeah. Now, just to put on my, well, let me read this comment real quick. And then this is from Michael. He says, BI tools like Tableau made it easy to connect data in a bunch of different places for analysis. But with a lakehouse, you can connect all the data there. Makes sense. And I think from a BI perspective, it does take this challenge that we have of connecting things in the BI tool. And really the issue with that is that metric that you derived from your CSV plus your database plus whatever else in the BI tool is now stuck in the BI tool.
Yes.
And we don't live in a world where data is only accessed through the BI interface. We never did. We pretended we did. But now we all recognize we don't. And so that is a huge problem. And I can tell you over the course of working at software vendors and being in consulting, this has always been an issue where you say, well, where's that critical number live? And it only lives in Power BI. It only lives in Tableau. Well, now we want to get it into this other place. How are we going to do it? And I think that this helps address that problem. Let me just put on my devil's advocate hat for your last answer. And just now let's imagine someone says, well, look, all this flexibility you're describing, you know, you're saying the pipeline doesn't break and maybe it doesn't fail, but now it has bad data in it, right? What's your answer to that objection?
Yeah, no, you're right. It could, I mean, it depends on in what way it fails or what way the data is bad. If we're talking about deduplication, that's your cleaning pipeline later on. If we're talking about it's got a weird column in there, you can, you know, that's also a cleaning issue. If it's bad, the whole thing's corrupt, roll it back to the time where it was right, and then fix the pipeline, and then insert the delta, you're good to go. So like, it depends on in what way the data is bad, like in all things. The rolling back really makes the process of correction so much easier.
Yeah.
And it's like seconds. It's not like you have to, I just remember dropping tables or columns or making a horrible mistake and then taking days for if it got fixed.
Yeah.
You know? So this is it's a game changer for pipeline maintenance and for data integrity, data quality in general. That's what I'd say. It depends on how it broke. And if you had to like do a full, then just go back to a time where it worked properly.
You know, I spent the first 10 years of my career working with a BI tool called Cognos, and Cognos did not have an undo button in the authoring interface, and it did not have a rollback capability when you did promotions between environments. And so the only way we tried to solve that is we had, seriously, it was a Word doc that was 6 pages of the deployment methodology. And it was like, you know, you followed it like a fighter pilot, like a pilot checklist, right? And you did every step, because if you promoted that content into prod, and you messed it up, you were hosed. Right. And so just the ability to do a rollback is huge. And I think a lot of this has to do, what I see over the scope of my career is one of the major themes is the migration of software engineering principles into data. And I think this is an example of that, right? The technology we use is maybe different, but our approaches are becoming more and more like engineering and less like how data was done when I started my career in the late 2000s. And I think this is good. I mean, like, this is one of the most positive things that's happened in the industry, in my opinion.
I agree. There's lots of cool tools like Jamio's Iceberg REST catalog, and you have to have one. It's called Nessie, and they have Git-like rollbacks. So you can make, like, every change that you make is a branch, and you can, like, just roll back in a Git-like manner that a lot of us, as we grow closer to software engineering, are more comfortable with. So I really I think more features in the data world are turning into things that would look more familiar to somebody coming from a traditional software engineering background. Again, I don't know what that's like, but
right. Yeah, I don't either. But this is what they tell me.
I think I do see that trend as well. And there's lots of exciting products that are like approaching that, like, I don't know.
Yeah.
Threshold.
I can remember when I first became aware of Looker, and I was scoping them out, and the one thing that stood out to me as really different from BI tools that had come before was Git integration. And in 2016, I was like, so what? Like, who wants Git integration? It just seems complicated. And now you jump forward a decade, and it's like every BI tool should have Git integration. I mean, this is obvious. And Michael again says, rolling back seems to be the big thing that is missed in the BI layer, which analytics as code and Lakehouses handling data modeling and transformations touches on that issue. And I agree, Michael. And, this is, I can tell you've been watching the show based on this comment, because this is what we talk about every episode. We have about 5 minutes left. So real quick, I need to thank our sponsors, Good Data. 2 papers I want you to read. Good Data's Analytics as Code and Good Data's Analytics Lake papers, both authored by Donald Farmer. Donald is an industry legend. If we were a better industry that had more knowledge of the history and the heroes who built our industry, you would all know who Donald is. Donald did a lot of the earliest research on in-database data mining and data science at Microsoft. He was one of the visionaries behind building up Qlik. This guy is a heavy hitter, and he's a great writer. So check out these 2 papers. One covers a lot of what we've been talking about today in terms of BI, not in terms of Lakehouses, but analytics as code, rollback, that sort of stuff in the analytics as code paper. And then the analytics Lake paper covers an exciting new architecture we're building that really is AI ready and has your data, metadata, and analytics objects in one application, so that AI can find all of those things very easily is one of the advantages of it. So thank you to Good Data for sponsoring. Check out those papers, read them, and let me know what you thought. All right. One last thing I want to touch on in the last few minutes we have here that I think we teased at the very beginning and we haven't really talked about, and that is this idea of on-prem lakehouses. So this is assumption now that everything's in cloud, and I think the wisdom of the industry, when I talk to people, what I hear mostly is, oh, nobody wants anything on-prem anymore. But that's not what I see. I do see that there are some use cases and some customers that are moving data back on-prem. So let's just talk a little bit about that. Do you see that as well? And how does Iceberg fit into an on-prem or maybe a hybrid cloud on-prem deployment strategy?
Yeah. So, I mean, I have a unique vantage point for this question because the company I work for, MinIO, is on-prem S3 compatible object storage. So our only customers will also deploy into the cloud for a hybrid use case, but the majority of our paying customers are on-prem use cases. And so we every time someone says, "Oh, everyone's moving to the cloud," I'd be like, like we have a lot of customers that we have a 2 billion Docker polls worldwide as of today, billion with a B. Candy Crush has 3 billion. So we're, like you can imagine, there's worldwide interest in on-prem object storage. And the biggest use case that people are using S3 compatible object storage is for Lakehouse. I mean, you can use it. Anything can be an object, but that's the biggest use case. The biggest MinIO deployments worldwide are for ginormous lakehouses. And it really, the reasons come down to cost, control, and compliance. And control and compliance can sometimes be the same thing, but depending on your reasoning. But cost is a really big one. So, and this is also these three things pertain to hybrid deployments too. So, I'll just interchangeably, you can just please just interchangeably accept that as true. So, cost. So every time you do a get and a put on, let's say, Amazon S3, you get charged. So we're not talking about egress fees of taking the data out of the cloud. Even if all of your stack is in Amazon, every time you get and put out of your S3, which is a transaction, right? It's a credit operation, you get charged. And that might not be very much or important to you because the storage isn't expensive, right? Storage in general, cheap as all get out. Cheap storage is like super duper cheap. If you are going Glacier, like you're putting data in object storage and you're going to keep it there and never touch it, the cloud is way cheaper, way easier than on-prem. Okay, I never lie. I'm trying to be fully transparent. It will always make sense for Glacier data to go into the cloud with their current pricing model. It's just really, really cheap. Storage is cheap. What's expensive is the transactions, right? Apart from egress fees, compute is expensive, right? We all know that. I mean, we've seen the cloud bills. The compute is expensive. And we're talking about storage, we're talking about gets and puts. So we found, we did a little bit of market research and found that it's about 5 petabytes, the difference between on-prem and of really hot data. I want to be clarified again. It's really hot data. So a lot of transactions, like a proper data lakehouse, about 5 petabytes of data, it becomes more cost effective to have that data on-prem than it is in the cloud. So, and that's not that much data. I have 3 petabytes on my laptop or something. So 5 petabytes of super hot data, it's less expensive to have it on the cloud. Now you can imagine the customers that are coming to us have a lot of data, a lot of very hot data. We've got lakehouses, customers with lakehouses in exabytes, multiple exabytes, and customers that we're seeing are like streaming use cases, Disney. We also have a company that's doing like autonomous car manufacturing. You know what I'm talking?
Yeah, I think I follow you.
Because they're doing because they have a ton of sensor data, right? And they're training models off of a ginormous, probably one of the biggest lakehouses in the entire world, right? We also have like American Express, MasterCard, companies like that have a lot of compliance requirements. And so they have to keep a certain number of data on-prem. They also need the performance to handle the kind of transactions that they're going through per day. You can imagine what they're processing, what kind of data they're processing, and how it has to be very, very performant and very, very large. So that's a kind of like compliance, that's GDPR. That's we also have a lot of customers in the government, Air Force, other 3-letter agencies, stuff like that, because when you can deploy it on your own environment, you can deploy a MinIO, Iceberg, and Dremio, for example, in an air-gapped environment, 400 feet underground with concertina wire all around. You can also, MinIO is actually a very small binary, so you can put it on a camera lens or an oil or like whatever, and you have an object storage that's available to you anywhere. Cruise liners use MinIO. So you can imagine why.
Yeah.
They need an on-prem. So edge case also very large because scale goes both ways, right? So I don't know. Does that answer your question?
Yeah, that answers it perfectly. I mean, that's my experience too, and I would love to geek out on this part of the conversation because we see this at Good Data too. We have acquired many large clients in the last few years because we have a fully air-gapped on-prem deployment, and we're probably the only modern analytics tool that offers that. Nobody else does. And so it is like, maybe it's a niche market, but it's a much bigger niche than I think our industry generally recognizes. But we are out of time, Brenna. So I would love to keep going, but we do have to cut things off here.
Thanks for having me.
Coming. Yeah, you've been an incredible guest. Where can people follow you?
Oh, I'm on LinkedIn. I'm on X. I'm on LinkedIn. My name is Brenna Buuck. You can just, I'm mostly on LinkedIn. You can just find me there. How about that?
All right. Thanks for joining us. And we'll talk soon.
Okay. Thank you.
Thank you. All right. I'm sorry to have to cut that one off, but I know a lot of you have lives to live, and so you can't stay late with me here. I want to thank you again for joining us on the Super Data Brothers show. We are wrapping up season 4. Season 5 will start in 2026, and so if there is a guest you would like to see or a topic you'd like to cover, let us know. Reach out to me, Ryan, at superdatabrothers.com, and say, hey, this is what I want you to talk about, and we will try to get it onto the agenda. We're putting that together now. All right. So, if you haven't already, click the like button, hit the bell, all that influencer stuff that I'm so bad at reminding you about. And we will be back next week. Until then, take care, everybody, and happy holidays. Merry Christmas. I am Ryan signing off. Take care. Goodbye.